Hi, welcome back to Moose and Chemistry. This is Graham's Law of Effusion and Diffusion problem lesson number 3. Okay, today's problem is how much faster is the rate of diffusion of oxygen, O2, than carbon dioxide, CO2. Okay, first of all, what is Graham's Law? Well, Graham's Law, simply put, is the rate of one gas over the rate of a second gas equals the square root of the molar mass of the second gas over the molar mass of the first gas. Alright, so now we know that's Graham's Law. We're going to put that back up in a minute, but right now I'm going to erase it. So let me go ahead and take care of that so we can get some extra space in here. Okay, so now let's go ahead and do our molar mass of oxygen. So we look at oxygen, which we're going to call O2. And if we look on the periodic table, oxygen has a molar mass of 15.99 grams per mole. So we're going to simply round that off to 16.00 grams per mole. All right? That makes it a lot easier. We have two oxygens, so we go 2 times 16.00, and that gives us 32 grams per mole. All right, so we're going to write this over here so we don't lose it. So oxygen equals 32.00 grams per mole. All right, so let's go ahead and erase this again and get some more space in here. All right, here we go. So now let's look at carbon dioxide, CO2. Carbon on the periodic table is 12.01 grams per mole. So you get 2.01. There you go. There you go. So now, oxygen is, again, 16 grams per mole. And let's go ahead and do the math. All right, this gives me 12 grams, 0.01. This gives me 32.00 grams per mole, right? So we add those two together and we get 44.01 grams per mole. So let's go and write this over here. 44.01 grams per mole. So let's go ahead and erase this. And what we're going to do next is we're going to put back the formula for Graham's Law of Effusion and Diffusion. So this is going to be pretty simple here, guys. Math is not that hard, actually. It's pretty simple. So R of 1 over R of 2 equals square root of the molar mass of 2 over the molar mass of 1. So we're going to make oxygen our R1 value. So our oxygen is what we're looking for. So R of 1 is going to be X, and that represents our O2. Our R of 2 is going to be our CO2. Okay? So we're going to count that as a value of 1. All right, so let's go ahead and set up the problem. X over 1 equals square root of the molar mass of carbon dioxide on top, which was 44.01 grams per mole, over the molar mass of oxygen, which is 32.00 grams per mole. All right, so the first thing we want to do is we want to get X over 1 equals the square root of 44.01 divided by 32.00. So let's go ahead and put that in our calculator. Divided by 32.00. There we go. And we get 1.375. That's right. 1.375. Now we take the square root of that, and X is going to equal, get the square there, square root of that, sorry, go. You get 1.173. 1.173. So what does this mean? This means that oxygen, which is the lighter gas, diffuses 1.173 times faster than carbon dioxide. And that's it, guys. See how simple that was? If you like this video, give us a like and consider subscribing so we can grow this channel. You guys be snarly, and we'll see you back here at Moosing Chemistry.